In this lesson, you will learn to interpret an equal sign in an equation as the phrase equivalent to. In mathematical terms, we use the word equivalent to describe items that are equal or are the same in value, amount, or meaning. This could be two numbers, two expressions, or two sets of numbers. Here is a balance scale. The arm of the scale is level when the items on one side of the scale have the same value as the items on the other side of the scale. In other words, when they are equivalent. Notice that the balance remains level when one red block is placed on either side of the scale. The blocks are of equal value. Therefore, they are equivalent to each other. A balance scale can also be used to show equivalence with non-identical items. Here I have two yellow balls and one red block on one side of the scale, while the other side has two red blocks. Since the scale is balanced, the value of the objects on one side are equal to the value of the objects on the other side. This means two yellow balls are equivalent to one red block. Here is another scale. Notice the equal sign in the middle of the scale. This tells us that the scale should be balanced. However, we can see that it is not. We have the expression 8 plus 4 on one side and nothing on the other side. To balance this scale, we need to place something on the empty side that is equivalent to the value of 8 plus 4. For example, we could place the number 12. Since 8 plus 4 have a value of 12, placing 12 on the opposite side would balance the scale. We could say that 8 plus 4 is equivalent to 12. We are not just limited to balancing the scale with equivalent numbers, however. We can also place an expression on the scale, as long as it is equivalent to the value of 8 plus 4. Here are some examples. Notice how in each case the value of the expression we use remains equal to the value of the original 8 plus 4 expression. Additionally, 6 multiplied by 2 and 24 divided by 2 are all expressions equivalent to 8 plus 4. We follow the same process regardless of which side of the balance scale we are working with, and regardless of the operation in the provided expression. In this example, we see we will be placing a value to the left of the equal sign, but the process remains the same. Given that the expression 45 plus 61 has a value of 106, we could place any number or expression that is equivalent to that value on the left side of the scale. Examples include 106 and 110 minus 4. There are many other possibilities. In this final example, we have expressions on both sides of the equal sign, 7 multiplied by 5 and 3 multiplied by 10. We no longer see the balanced scale, but the equal sign will serve as our reminder that both sides of the equation must be equivalent. Right now, they are not equivalent. 7 multiplied by 5 has a value of 35, while 3 multiplied by 10 has a value of 30. To make these expressions equivalent, we need to change the value of one side of the equation to be equivalent to the value of the other side. We can choose to change the expression on either side, and as we've seen before, there are a variety of solutions. By adding 5 to 3 multiplied by 10, we achieve a value of 35, which matches the value of 7 multiplied by 5. We can now see that 7 multiplied by 5 is equivalent to 3 multiplied by 10 plus 5. In this lesson, you learned to interpret the equal sign as the phrase equivalent to by balancing equations in a variety of ways.